Alrighty, hello my people. I hope we are doing well. This is the first video for 4.4, which is trigonometric functions of any angle. From this, basically, like I've said before, 4.3 and 4.4 are really sort of they're one section, but there's just so much in there that they've, for the sake of making it manageable, broken it apart into two. And you'll notice that the logic of this one follows pretty clearly the logic of the last one. Wherein when we are dealing with the unit circle, we remember that we had sine theta was equal to y, right? And cosine theta was equal to x. Well, the reason why that is because it was the unit circle, right? And, you know, that opposite was being put over a 1, and that adjacent was being put over a 1. What we have here when we get to, you know, branching out and dealing with points within the plane or triangles whose top vertex are not necessarily on the unit circle. I mean, they could be, but the thing is that it doesn't really matter, okay? What matters is the fact that you need to basically be, willing to sort of substitute in for that 1 the fact that we now have an r, okay? And of course, the r shows up in the secant and cosecant, secant, of course, being the reciprocal of cosine and cosecant being the reciprocal of sine. And now that we know that, we can go ahead and venture forth and do a couple of problems. And we're basically just going to play with this logic for the next couple of videos and hit it from a couple of different vantage points. And the problems that we have here are ones that are going to allow us to do that, okay? And so the variety that we have here is really just an excuse to kind of play with these topics so that we can understand them as well as we possibly can. Now, this is really two problems, so I'm going to go ahead and split this down the middle. Let's go ahead and read the instructions. It said, determine the exact values of the 6 trigonometric functions. Now, the first one is going to be really easy because it is already in the first quadrant, right? And so we don't have to deal with any reference angles or anything like that. We know that if we sort of drop this down right here, we know that this side right here, this adjacent side is 3. That was our x. This is a 1. And of course, when we square 3, we get 9. Square 1, we get 1. The sum of which is 10. So my hypotenuse over here is the square root of 10. So, you know, we can just, you know, read our 6 trigonometric functions and their ratios right off of this triangle. Let me go ahead and set up all 6 of them, and we will just go to town. Sine from this theta right here is going to be the opposite over the hypotenuse. So it's 1 over root 10. The reciprocal of which is root 10. Cosine is, instead of being 1 over root 10, it's going to be the adjacent, or 3 over root 10. And this is going to be root 10 over 3. And tangent is going to be the opposite over the adjacent, which is 1/3, and cotangent is going to be 3 over 1. Now, of course, we're going to rationalize these denominators. And we get 3 root 10 over 10 right here. And those are going to be our 6 trigonometric values, our ratios. Now, when we get to the next one, what we need to recognize is that we are still going to drop this, this altitude right here in order to create this angle. But we are going to be dealing with a triangle that deals with what is sometimes referred to as theta prime, which is the reference angle, right? This angle right here is greater than 90 degrees. And therefore, in order to create a triangle, you're not going to wind up getting a right triangle. In order to get a right triangle, we're going to have to drop it down over here and sort of use this as not a substitute, let's call it a surrogate triangle to basically tell us more about this theta right here. But in doing so, we notice that this side right here is -4. I had to draw an arrow because the ordered pair there is getting in the way. And that right there is +4. Okay, well, -4 squared is 16, +4 squared is 16, 16 plus 16 is 32. And so this hypotenuse right here winds up being 4√2. Which, of course, we should have figured out from the fact that it's a 45, 45, 90 right triangle, and those are the sides that are usually given to us for that special right triangle. Now, because we are in the second quadrant, we have positive y values, which means our sine ratio is going to be positive. But we are to the left of the y-axis, which means that we are going to be into negative x territory, and our cosine ratio is going to be negative. So in terms of sine, we know the opposite over the hypotenuse is going to be 4 over 4√2, which of course is 1 over √2 and √2 over 2. Cosine is going to be this adjacent right here, -4 over the hypotenuse, 4√2, which is -1 over √2, or -√2 over 2. And tangent is basically just, this opposite over the adjacent, or if you want, just sine over cosine, which is going to be something over its negative, which gives me a tangent value of -1. Cosecant theta is going to be √2, right? Because we're basically going to reciprocalize that one right there rather than doing it here and having to re-rationalize the denominator. Secant theta is going to be -√2, and cotangent, we're going to do the really, really difficult chore of taking the reciprocal of -1 and, of course, arriving at a very shocking -1. Okay, let's go ahead and take a look at another perspective on this. By the way, these, for those of you that were not in class, these problems are taken from the same problem set as your homework is going to be, and therefore they're going to be very much like the problems you're doing in your homework. I wanted to give you that sort of continuity there. Now, let's go ahead and zoom out just a smidge so we can see a little bit more. Find the values of the 6 trigonometric functions of theta with the given constraints. Now, we are given a function value of cosine theta being equal to 8 over 17. Okay, 8 over 17, that means that my adjacent is 8 and my hypotenuse is 17. Now, hypotenuse is always going to be positive. The fact that my cosine ratio is positive means that it's going to be where x is positive, and x is positive, of course, over there in the first and the fourth quadrant, okay? Now, because this cosine value can reside in either one of those, they've given us a further constraint to take away the ambiguity, and tangent theta is less than 0, meaning tangent is negative, okay? Okay, so if I'm in either the first or the fourth quadrant according to my positive cosine, but tangent is negative, we're going to be down here in the fourth quadrant, okay? Now, if we go over 8 over 17, it's just a little bit past 1/2, okay? And so it's going to be just a wee bit past 1/2. And then we're going to go ahead and draw this vertical line right here, confirming, that basically this angle and this angle fit the bill in terms of that first piece of information and our cosine ratio. But tangent being negative is going to ensure that what we're really after is this triangle right here with that reference angle theta prime. And we'll go ahead and color code it so that it's just easier to see, okay? Now, remember, it's not the actual size of each side of the triangle that really matters, but their ratios. And as long as you use these, it doesn't really matter if they are accurate by themselves. As long as they are accurate in terms of their relationship to each other, you're just fine. So we know that it's going to be 8 on the adjacent, it's going to be 17 on the hypotenuse, and now we simply need to figure out what 289 minus 64 is. Okay. Now, 289 minus 64 winds up giving us 225. 225 is the square of both positive and negative 15, and it's going to be negative 15 since we're going down in a y direction. Okay. And for those of you who are sitting there thinking to yourselves, how did he do that in his head? Well, I grew up in an era where we didn't concentrate on calculator work quite as much, and so I know my perfect squares. And plus, I'm a math teacher. So let's just double check. 8 squared plus negative 15 squared is 289, the square root of which, whoops, wrong button. The square root of which is 17. Okay. This is, as you might have guessed, a Pythagorean triple because all 3 of those values are indeed integers. Now that I have my complete triangle, all 3 sides of it, I can go ahead and just start reading those ratios right off of the triangle. And I know that my opposite over hypotenuse is negative 15 over 17, the reciprocal of which is negative 17 over 15. Cosine is going to be 8 over 17. Of course, we already knew that because that was basically in the question stem, reciprocal of which is 17/8. And my tangent is indeed negative. It is negative 15 over 8, and the reciprocal is negative 8 over 15. Okay, let's go ahead and let's look at another one. We noticed right here that we have cosecant is equal to 4. Well, cosecant is equal to 4. That's all well and good, but what that really means is, here's the thing. We are used to dealing with sine, cosine, and tangent. When it comes to the 3 new ones, some of you will get to a point where you're able to think in terms of them. Others, you're just gonna be making recourse always back to its reciprocal, and that's fine. I really don't have a problem with that. So we know that cosecant being 4 is equal to the ratio of 4 over 1, and its reciprocal, of course, is 1/4. If sine is positive on the unit circle where y is positive, right? And so, if we try to sort of eyeball this, if this up here is 1, what we have here is we have these. We have basically, that is true of this angle measurement and that angle measurement. So let's go ahead and put both of those here on the unit circle. Okay, but we know that that ambiguity is going to be resolved by this constraint. This piece of information fits either one of these angles, but cotangent being negative, it cannot be the one in the first quadrant, because in the first quadrant, everything is positive. If cotangent is less than 0, we are dealing with this triangle right here, okay? And if it's 1/4, okay, that means that this is 1 and this hypotenuse is 4, which means that this side right here is root 15. because the hypotenuse is 16, and then you'll subtract 1 from it before taking the square root of whatever variable you plug in there for that missing side, and it's root 15, which is great, but root 15 is not the actual answer. Remember that you are going in the negative x direction, so it needs to be negative root 15. Now we can read the rest of them just right off of the triangle, and this becomes negative root 15 over 4, and this becomes negative 4 over root 15, which of course becomes negative 4 root 15 over 15. And this becomes negative 1 opposite over root 15, right? Opposite over adjacent. Or, I mean, you can obviously think about it as sine over cosine, and then, of course, the denominators in the 4 just sort of evaporate. And this becomes negative root 15 over 15. Now, when we take the reciprocal, of course, we're going to be looking at that version of it, and we're going to give it negative root 15. And that, as they say, is that. Okay. Let's go ahead and move on to another type of problem, which gives us another perspective on what's going on. We have 3x minus 5y. You're like, wow, that's fantastic. What are we doing with an equation of a line? Well, it happens to be a direct proportion style linear, meaning that there's no constant, meaning that its y-intercept is 0 and it goes through the origin. That would, of course, be the only way that we could use a linear function or a linear equation in this capacity to talk about angles in standard position. Otherwise, they're, basically the unit circle is of no help to us, okay? Now, when we solve this, and of course we're not used to looking at stuff in standard or general form, so we're going to change it over to slope-intercept form, which is the way that we like things. And it's going to be, up 3 over 5, up 3 over 5, down 3 over 5. And then we're going to go ahead and draw our linear. Okay. Now, we notice that, if you were to sort of imagine a unit circle kind of right on top of here, you notice that basically you're going to create 2 points of intersection wherever that circle is. Of course, it doesn't have to be the unit circle. It can just be circle. You're either going to get a triangle over here or a triangle over here. Now, we are told that it is the third quadrant one over here. Now, it says, find the value of the 6 trigonometric functions by finding a point on the line. Well, here's the thing. It can be any point on the line. And the reason it can be any point on the line is that any point, once you actually use it to create a triangle, all of those triangles are going to wind up being similar triangles. And of course, similar triangles have proportional sides, and proportional sides give you identical trig ratios. So what we're really doing is we're really looking at this theta prime, and I'm sorry about the Cartesian plane that I actually chose for this. The lines are too dark, but this is why I'm kind of resorting to colored pencils or pencil highlighters or whatever you want to call them. But we know that this right here is negative 5. This right here is negative 3, and 9 plus 25 is 34, so this is root 34. I have all 3 sides of my triangle, and now I can just read my trig ratios right off of it. From this reference angle, theta prime, I have opposite over hypotenuse, so negative 3 over root 34. Adjacent over hypotenuse for the cosine. Let's go ahead and do both of those reciprocals before we rationalize the denominator. And we get root 34 over 3, negative of course, and negative root 34 over 5. Let's go ahead and rationalize these denominators. We multiply by root 34 over root 34. And you kind of wish that 34 you could actually simplify as a radical, but unfortunately it doesn't have any perfect squares inside of it as factors. 34 basically simplifies down to 2 times 17, and that's about it. Now from here we have 3/5 being the opposite over adjacent, and this of course becomes the reciprocal of 5/3. And that's kind of a, I mean, not that it's a hugely clever way of asking the question, but it certainly allows us to think about it from at least a little different perspective. So that's kind of nice. I'm going to go ahead and end this video since we're a little over the 20-minute mark. I find that that's kind of a nice duration for each video. We're going to continue on. Those of you who were in class, you'll notice that these are the same style of questions we went over in class. They're just different ones, and you're right, okay? That's very, very intentional. So basically, this will be a nice supplement, one to the other. And if you have any questions on either, for those of you who were not in class, if you have any questions on the video from class or the videos here and the problems that we're doing in them, please do shoot me a message and let me know of the problem, and I will attempt to address it quickly. Bye, guys.